Yes. Hey. Welcome back. Let us solve the question party in town. And even though there is party in this town, there is no party in my town. Mainly because I just recorded the video for this. And as soon as I went to look at that video, my recording software crashed, deleting the video in process. So let's have a party again in the town. So what is happening? Geek town has N houses, number is from Mount N, and they are connected via N minus one bidirectional roads, and that is given in the form of an adjacent list, and you have to find the house to host the party such that the distance to the maximum house from the current house is always minimum. So what does that mean? So distance to the farthest house is minimum. So if you see this example, if you host the party from one, the maximum distance house is 3 and 4. That means the distance is 2 for the farthest house. But if you host the party from 2, as you see, all the nodes are connected to 2 itself. In other words, the maximum distance to all the houses is 1. So your answer will be 2. So you have to do that. So how we'll do? As soon as you see this, only one thing should come to your mind, and that is BFS. And this straightforward BFS question. So what you will do? You will have a result variable which will be initialized to some very large value, and then you will go through each node or each house, and for each house, what you will do? You will find the distance to the farthest house from each house, and at the end of the day, you will take the maximum distance for the farthest house and compare it with the result in such a way that the result value is nothing but minimum of the result variable and the maximum distance. Yeah, it is like super straightforward. So we will directly get into so result is nothing but total infinity. And since our the mappings are already given in the form of an adjacent list, there's no need for us to do anything else. So for every house in the range 1 to n plus 1, mainly because we are given that the houses are from 1 to n. So we are excluding 1 and excluding 0 and including n plus 1. So first, what we'll do, if you are doing any kind of traversal, then you will know that you don't want to get stuck in an infinite loop going front and back between office here 1 and 2. So you will have a visitor set, and then you'll have a distances array, which is nothing but currently the distance to all the houses is 0. There's no need for to do n actually. Yeah, because the directions are as it is a n minus one directional graph. And then what you will do, and since your distances, and then you will have your queue, which first you will have your current house with the distance of 0, because the house to current house distance will always be 0. Imagine you're in your house, the distance between you and your house is always 0. And then what you will have, uh, so since you're already in your house, we will add it or visit it so that we don't visit it again. The, yeah. Now what we'll do, now let's start our BFS. So while we exist, first let's get the current house and the current distance, nothing but, yeah. And for every neighbor in ADJ, since the mappings are already given the form of an adjacent matrix, you can directly use that. So for every neighbor in the for every neighbor of current house, which is nothing but adjacent list of current, what you will do, if your current house, like in other words, if the neighbor is not in visited, that means you have not visited your neighbor yet. So what you have to do? You have to visit your neighbor, which is always at a distance of 1 from the current node. And that is one good thing. This is not a weighted graph. This is an unweighted graph. That means that the distance to the next house is always 1, or else we have to use Bellman-Ford algorithm to solve this. But since this is unweighted graph, and this becomes very simple to do. So yeah, if neighbor not in visited, what you will do? So first, let's visit our neighbor. So visited, yeah. And now we will add our, what do you call, the distance to the neighbor to the current adjacent, I mean to the current DQ, because we have to process our neighbor also. And what is the distance to the neighbor from the current house? It is nothing but the current distance which you have traveled plus 1. And the same will be true for your distances array. Distances at the position neighbor is nothing but the current distance plus 1. Yeah. And now what you have to do? Now this is a bit, what do you call, confusing part. So for your result, will be nothing but the minimum of result and the maximum of your current distances. What you're doing, you're finding the minimum distance between the what do you call you're getting your answer in the form of the minimum value of the further distance to the current house, like further distance to the house from the current node, and the already found minimum distance to the farthest house. So there might be other node, like for example, for first it will be since it's one, the result will be two. But as soon as it gets to two, it will see the distances to all one, three, and four are one. So let's consider the first array. So when you do from one, so it will be zero, 1, 2, and 2. So the result value will be maximum of this and the minimum of result which is infinity. So result will be 2. But as soon as you come to the second array, it will be 1, 0, 1, 1. And the maximum of this is 1. And the minimum of between this and the result is nothing but 1. And that's your answer actually. The same thing happens. How many ever nodes are there? And yeah, now at the end of the day, you can actually return your result. Let's just compile and run it on. Okay, it's not add, it happened. Yeah. Let us submit once and see what happens. Okay, so we have made some blunder. So let us see what blunder we have made. The current distance is nothing but q dot popular. This one and q has been again and value this. The current node and the current distance is nothing but the q dot popular for every neighbor in your current adjacent list. If the neighbor does not exist visited, so if you visited dot add neighbor, q dot append the current neighbor and the current distance plus one. Yeah, that is because this should be done only after you process all the nodes, not before. What was happening was I was what you call updating the result even before all the nodes were processed. That's why the distance to the next node is always one. That's why whatever it did, the result would always be one. Yeah, and yeah, first attempt was when I actually recorded it once, and then my software crashed and I had to record it again. And second attempt was this what you call tactical blunder where I had unexpected indent, and third one was correct. Yeah, but yeah, that's all for it. If you see, as soon as you see questions like finding the minimum distance and all, you should either think of Bellman fold or Dijkstra, or you can do menial the breadth first search also, depending on the problem. And this was a very easy breadth first search problem. But yeah, that's all for it. And thank you for watching and goodbye.